Hi, everybody. Can you guys hear me? Great, thank you. Just letting some more people into the meeting here. Okay. We'll go ahead and wait just a few more minutes for more people to come through.
Hi, Claire.
Hello, hello.
Can you hear me, Claire?
Yeah, I can hear you. Can you hear, hear me?
That's very good. You're perfect. So.
Okay, great.
And the recording is running.
Fantastic.
Yeah. And how many people are there? Few.
Yeah.
Okay. This is very good. And I will switch off my microphone. I will not interfere with your work, Claire. I just want to, at the beginning, make sure that the recording works, for all the people who don't. So, and enjoy.
Sounds good. I think we'll just keep waiting for a few more minutes for more people to come in. Alrighty, I think we'll go ahead and make a start. Hi guys, my name is Claire. I am the demonstrator for this subject. You might have seen my name floating around a little bit. But today I'll be helping you guys and showing you the climate model that you'll be using for your upcoming assignments. So at any point through the session, if you have any questions or anything, feel free to message the chat or turn your microphone on and just let me know. Happy to help. All right, so I'm going to go ahead and share my screen. All right. Can you guys see my screen? Is that working well? Anything? Great. Awesome. That's fantastic. Okay. So, to get to the climate model, there are a few different ways you can do it. There was a link on this Teams meeting invite, but there's also, it's in the assignment instructions as well. So if you click that hyperlink, you get taken straight to this web page here. And there's quite a bit on here, but don't go too far, because right on the top here, this banner is actually a button. So if you click anywhere within here, it will take you to this page. So there's a few different options, but the one that we are the most interested in is this first green one. So we're looking to deconstruct the mean climate. So go ahead and click that. And it's going to give you these two options, these two different versions. It's really important that you click the basic version. So the standard version is a bit more advanced, and more importantly, it's going to give you guys the different answers for your assignment. So ignore the standard version. We're going to go right to basic version here. So go ahead and click that. And this is what comes out. All right. So there's a few different things going on here. So basically what this is doing is it's modeling the climate of the world. So this top left one is experiment A. So we've got all the different factors of experiment A here on the left side. And then experiment B on the right side up here, and all of the different factors on that side as well. So let's go ahead and for experiment B, we're going to click all of these check boxes to add in all of these different factors. First thing. All right, so going to make sure that these on the right match these on the left, and we're going to hit update. So right now they're just running off of the last settings, so we have to hit update for that to go through. So you can see now that these top two are identical. So basically what this is doing is that this experiment A, we're going to use as basically our control world. So we're going to keep all of our options on. This is what it looks like now, basically. This one on the right, we're going to use as our experiment. So you're going to be able to change different things, remove, add different factors, and then see what that would look like played out in the world. So up here, right along the top of the maps, you can see experiment A, global mean temperature of whatever it is, Celsius. And then on the right, we've also got global mean right now. So at the moment, they're completely identical because the same factors are clicked for each one. And this bottom map here is the difference. So it's telling you, yep, they are identical. There's no differences between these two. And you can also see on the top of this map, you've got the difference in temperature between A, which is our control, and B, which is our changed model. All right. Temperature is by color gradient. So you can see that our poles here are much colder, of course. And you can just kind of look at the color scale to get an idea of what the temperature looks like down there versus our tropical, more humid climates. You can see those a bit higher. Okay, another thing from this main page, you can see that it's kind of shuffling through different months. So it's giving you all the way January through December. It's showing you shifts in, sorry, in the global temperature throughout the year. So I can go ahead and stop that. And you can see we're in June at the moment. But you can move this little slider bar right down here. You can move this to hit whatever month that you want. All right, so say we want to go to March. All right, so we can see that you can see, again, they're exactly identical, but you can see, right, it's nice and warm right in the middle, and then on the poles, it's colder, and you can see that shifting throughout the year. Okay. So let's see if you can also use this, sorry. So you can use this to look at global mean temperatures, but you can also look at the shifting in regional areas as well. So if we take South Africa, for example, you can see that let's go all the way to January, you can see temperature-wise, it's sitting at about 15 to 20 degrees, upwards of 25, right around here. And as we go through the year, you can see just how much that changed. The temperature is lower, and we know this is austral winter, right? You see it's our winter time as well, right around June, July, and then it warms up again. So not only are we looking at the global mean temperature, but you can look at the changes in the regional temperatures as well throughout the year. Okay, and for your assignments, it's okay to just use visual estimate values. So we're not asking you to download data. Don't go ahead and just forget this button exists. We're not asking you to download and analyze the data. Just look at the visual shifts in the temperature. So like the poles, for example, you can see how that changed throughout the year. Okay, so that's what this main series looks like. If we go back to our values now, so along each side, you can see each experiment, we've got the exact same values: ice, clouds, oceans, atmosphere, CO2, and the hydrological cycle as well. So if we are interested in CO2, you can see it's right here. And there's actually buttons on the right side of each of these to go ahead and to explain each of them to you guys. So if we look at CO2, let's go ahead and click that button on the right side. It gives us an example, sorry, it gives us an explanation of what it is. So the atmospheric CO2 concentration changes the emissivity of the atmospheric layer and therefore changes the amount of thermal radiation absorbed and emitted by the atmospheric layer. The amount of change in the emissivity of the atmospheric layer also depends on the amount of water vapor and clouds because the radiation absorbed by different trace gases or the clouds interact in log scale manner. So it will generally heat the surface. So these give you really, really good detailed explanations of what they can do and what they will do, but you'll also have to rely on looking elsewhere and Googling, doing your research, looking through the lecture notes and seeing how this is influencing the world. Okay, so we're going to leave experiment A all fine as it is. So you can see we're going to keep all of these checked because this is just our control measure. But if we go over to experiment B, which is this top right map, remember, we can go ahead and uncheck CO2. So remember, nothing will change up here if you've unchecked something, nothing will change until you update the figures on this bottom orange square. Gotta hit that. So we're gonna let that load. And you can see there's quite a difference. Right, so it's going to cycle through the year. So you can see that change in color. So remember, this top left one is our control. So this is the world. And our top right one is our experimental world. Right? And then this bottom one here is the difference. So if we look at this top left map and we look at the global mean temperature, it's sitting, let's say we stop at a March again. It's sitting right at 12.2 degrees Celsius. So that is the global mean temperature. in March. But if we pop over to our experimental world, experiment B, we've got a global mean temperature of 2.28 degrees Celsius. So you can see there's quite a shift. And so you can look at the numbers there to see that change. But also you can pop down to this map on the bottom here, and it's going to show you the difference. So this is world A minus world B, and it's going to give you a global mean difference, right, of 10 degrees Celsius. Okay, another thing you can do along here is pop up to this tab, this time series tab. Okay, and this is going to show you experiment A versus experiment B. We're now in graph form instead of map form. So we've got surface temperature along the y-axis, and then we've got the month of the year along the x. And you can see that experiment A, which is our control up here, has a much higher global mean temperature throughout the year than experiment B. Very similar trend, but you can see there's quite a bit of difference if you take CO2 out of the picture. All right, so you can go ahead and uncheck. You can do what would happen if there's no ice, let's say, and you can see how that changes throughout the year. Okay, so this is all going to be really important for your assignments. You're going to need to know how to manipulate this, what you're looking at, especially, and how to answer different kinds of questions. So again, you're looking not only at the global mean temperature, but also regionally, what's happening. So if we were looking at the northern poles, for example, so up here, and we took out, let's say we took out clouds. Okay, so this is now showing there's no clouds whatsoever. Let's go back to March. Okay, cool. So if we are in, let's go to January actually. So that's winter in the northern hemisphere, right? We've got quite a difference, hey? So it's winter in the northern hemisphere and it's summer right in the southern. So you can see quite a bit of difference up in the North Poles. You can see that temperature sitting right around 20 to 30, negative 20 to 30 degrees Celsius. And up here, you're more close to -10, -5, even 0. All right. But you can see in the tropics here, there's quite a difference. Incredibly high temperatures, and they're almost pretty much unlivable at that point. And then, so again, let's go with this is summer in our side of the world. But if we go to our winter, you can see how much that changes. Basically, the entire world is on fire. But yes, so you can see that. You can also look at the numbers for that as well. So visually estimating what the temperature degrees, what the temperature is looking like, but also looking at these mean values. So in experiment A, which is our control again, we've got a global mean of 15.6 degrees Celsius. And then in experiment B, we've got a global mean of 39.2. So quite a difference. Okay, and if we go into this time series, again, you can see quite a difference. So in your own time, you can play around with this as much as you want. You can add, remove different things. Yeah. Okay. Were there any questions with that one? Feel free to turn your microphone off if you have a question. Otherwise, type it in. Alrighty. Jochen, if you're still there, do you have anything else you wanted to add? Not sure if he's still around.
Hang on. Can you hear me?
Yeah.
Most important is that you read all the instructions carefully, because each assignment only deals with one setting. You have to be careful with the signs that you don't confuse a minus with a negative, with a plus sign. You know, you have to not confuse warming with cooling. And other than that, I mean, this was a relatively quick run through. I just suggest that you take your time and really play around with it. You know, read a little bit the instructions.
Mm.
And then in terms of the assignment itself, there are many multiple choice questions where you are asked about specific regions, or you are asked about the global temperature change, but there are also essay type questions. You know, I wrote that in the announcement, but there are questions that you can't answer within 5 minutes where you actually have to study a little bit. Okay? Where the answer has to be correct. If you write the wrong answer, you get 0 points for that subpart of the assignments. In terms of the demonstration software, let me just go. That's still open, isn't it?
Yeah.
I am not sure whether you actually looked also at the time series, which is actually a very interesting thing. If you click at the top on time series, you actually get a very nice summary of the monthly change of the temperature in degrees Celsius as a time series over the year. Okay, and you can see the two experiments. Experiment A is everything, you know. Experiment A is the top curve, and experiment B is the bottom curve, and that actually gives you a really nice idea. And these are global mean temperature. It gives you a really nice idea that you actually get a shift in temperature throughout the year. You know, you can see that there's a little bit of seasonal cycle. Yeah, in June, July, you see that there's a little bit a peak in both curves, but overall, you know, that's the effect. Is it, you know, and you can do that for any parameter setting. It's worth looking at the time series as well to get a good understanding of what's happening. And that's probably the comments from me.
Great. I'm just gonna pull up the chat here.
And just one last thing. It's really your chance. The students, ask your questions now. You know, because this is your chance. Don't send me hundreds of emails afterwards and you said this and Claire said this or that. This is really your chance now. If something was unclear, you want to see something again, this is your chance. Raise your hand, type in a question. You don't need to use your microphone, okay? Okay, thank you.
Jochen, I think you can answer these two questions that we've gotten. So can they open the assignment and see the questions and then go back into it in another session? Or does it need to be done in one go?
Oh, I am not sure.
Yeah.
I am not sure. I am not sure whether you submit. Is there? I have to check that. I have to go into student. Maybe other students can answer that. If you can just in a multiple choice test, if you only answer 3 questions and keep 2 questions unanswered, and you go out of it, whether there is a submit all button or not, or whether you can save drafts. I am not sure. You can.
Someone's piped in and said that you can go back because there's no time limit. So you should be able to save and go back. Just to
Yeah.
be safe, though, I'd probably keep your answers on a separate Word document. Just to be safe, for that testing one.
Okay. What I would probably do is I look at all the questions and I just try to find what is the essay type of question. And this one I would copy and paste and work that out. And then you can just do it everything in one go and just copy and paste your answer then back into that box.
Would you like a reference list
And
for the
no
written
reference.
answers?
This is
Yeah.
general knowledge. You know, this is your knowledge and you should get it from the lectures, you know. There's also text. If you look at the assignment, there's actually an appendix where there's quite a bit of explanations provided, 1-2 pages of explanations in the assignment itself. If you read that, you should already be able to give the answer, to provide the answer. Okay, but no references or whatsoever. It's not required. Super. Questions? Come on, ask more questions.
Connor, did you have a question? I saw you had raised your hand. Cool.
All right. All right. It looks like there are no questions, but really don't take it too easy, because I know from my experience, we've been running this course for quite a number of years. It's always a confusion if you look at difference graphs. It's always students have problems with the graph world A minus world B, the difference plot. Okay, you always have to think about it and say, oh, what happens now? What's the effect if you switch off CO2? Does the world get warmer or does it get colder? And I myself have big problems with plus minus or with east west or these sort of things. So really take your time, because if you confuse the sign, you get everything wrong. If you call something a warming, it's a cold, you know, and it's a cooling. So really take your time and think about it. You know, because you all want to get your high distinction and very high marks.
So Lily has asked for clarification on the wording of one of the questions. So what is the global mean temperature change due to carbon dioxide in Northern Hemisphere winter, i.e. January? Yes, so when it says change, that's meaning difference. So you're looking then at the difference between A and B. A again being your control. And then if you're looking at specifically, you change the slider over to January, and then you can look at yeah, great.
And hang on, just in addition, the question really says, what is the change when adding CO2 to the atmosphere? So you actually have to compare the situation without to the situation where you have CO2 added. Again, this is the sign problem. Is that now what, you know, does CO2 cause a warming or does it cause a cooling? You know, so you have to be also careful reading, understanding the question. So what does he really want to know? Is it A minus B or is it B minus A? You know, but it's just common sense. So don't get confused. You know, this is what you learn in the lectures. I mean, it would be a little bit bizarre to claim that CO2 causes a cooling, you know, because then nothing would work in the out anymore, you know.
Yep, good question.
Yeah. Okay.
All right, so someone's opened the model at the same time that I did with the same settings, but their global mean was different from my version. Did you have the basic version running versus the standard? That's probably going to be the biggest thing. Make sure that when you go into the model that you're choosing the basic version. So remember, it was right at the beginning there.
And logic tells you it can't be the same settings if you get a different results. You have to be confident. If you get a different result, there must be something different. You can't claim I used exactly the same setting. No, because this is, it's evidence-based. This is what science is. You get a different result, oops. And I don't think that different browsers make different results.
It shouldn't. Nope. It shouldn't.
Oh, yeah. There's a very, very important note regarding that, actually. You always have to update the figures. If you change a setting, scroll up. Sometimes you can't see it. At the bottom of the page, there is an update figures. If you don't press this little button, you see the previous results. So you have to click it, and then comes the update. And then you see. This can lead to errors if you don't update the graphics. I think Claire said that you said that several times.
Yeah, yeah.
But it's just an important thing where you have a little break, have a look. Sometimes these buttons are hidden because they're just at the bottom of the page, which is a little bit nasty. Sometimes you lose so much your progress because you didn't see the save button in the bottom right corner of something, That can be really annoying. But here, update, and then you see you get the same results.
I think that's also the value in having these sessions recorded, as well as that you'll be able to go back and make sure that you had followed all of those steps, make sure you hadn't missed anything. And then if you're still having those issues, send an email.
Yep. So any more questions? Let's see.
Yeah, so we just got a new one. Asking for clarification on a question. What is the regional temperature change in high and mid latitudes in the Northern Hemisphere in winter January? So January. So you're asking whether you should then keep CO2 ticked in both experiments? You would then, yeah. Because the question's not asking you whether there's a change in CO2, it's just asking you a change in the temperature. And so that's that regional shift. So you'd be able to look at the map and see color gradients, what's changing throughout the year.
Maybe there's also confusion because what you need to do is you have all boxes ticked and only untick one box on the right-hand side. So you only take away the CO2. So you don't thinking that everything is blank and you just press one box is incorrect. So you have everything ticked, means everything is enabled. The entire climate model is perfectly there. And then you take one away. So you unclick CO2, and that's the only thing you do. Okay, and that does not become clear from Rumi's question, whether, So really read the instructions. The instructions tell you have everything switched on and only CO2 in experiment B switched off. Okay, very important. All right, this is good. That's almost the end of the session, isn't it?
I think so, yeah.
Any more last questions? Is everybody happy? Or not too
confident? Awesome, we've got one thumbs up.
Okay, so then we can close this meeting, and I will post the video. Okay, so thanks for tuning in.
Thank
Thanks,
you,
Claire,
everyone.
for this wonderful session.
Yeah.
Alrighty, see you. You get thank you. That's so sweet.
Thank you. All right, and have a great week, everyone.